After learning the patterns in looking for basic derivatives, we figure out how to work on higher order derivatives. This is differential calculus. Let's have a peek of higher order derivatives. The first derivative, which everyone is already familiar with, is also written as y prime. But this is interpreted as dy over dx. In physics, aside from having the first derivative as a slope, it is also termed as the rate of tangency, velocity, or force. A derivative higher is called the second derivative, which can be called y double prime. So from dy over dx, take further derivative, which then can be written as the second derivative of y with respect to x. This type is also termed as the rate of curvature, acceleration, or yank in physics. Further down the line, a higher order derivative is the third, which can be termed as y triple prime. And taking it from the second derivative, we take its derivative again, resulting to the third derivative of y with respect to x. This is also called jerk or tug. There is also the fourth derivative, and this time we can term it as y quadruple prime, but it is still written as the fourth derivative of y with respect to x. This order is also termed as jounce. Instead of 4 primes, this is denoted by y raised to 4, and the force enclosed in parentheses, which makes it different from the exponent 4. To show the process of searching for the higher derivative, let's work on an example. Find the third derivative of the function y as equal to 3x raised to 5 minus 2x. First is to take the first derivative. With the function, take d over dx for each side. From the right side, distribute d over dx on each term. So dy over dx then has the derivative of the first term, 3x raised to 5. Then also the derivative of the second term, 2x. To start with taking the derivative, take the constants out of the picture and make them as coefficients. Dy over dx is then the constant 3 attached with the derivative of x raised to 5. For the second term, take out 2 from the derivative of x. Dx over dx is 1, simplifying the second term. Now let's differentiate. Dy over dx is the constant 3 and the derivative of x raised to 5, which is 5x raised to 4, with dx over dx. Then place minus 2. Dx over dx is 1. Simplifying terms, dy over dx then becomes 15x raised to 4 minus 2. This is the initial derivative. We then continue with the second derivative. So from dy over dx, we differentiate it again. Repeating the same process, distribute d over dx to each term. So the second derivative of y with respect to x is then the derivative of 15x raised to 4, then the derivative of 2. The second term will then be zeroed out, as it is purely a constant. The next step is placing the constants apart from the variables. And since there is only one term left, we take out 15 and take the derivative of x raised to 4. We can then differentiate from here on. So the second derivative of y with respect to x is then the constant 15 multiplied by the derivative of x raised to 4, which is 4x cubed with dx over dx. Again, the fraction is equal to 1. So the second derivative is simplified as 60x cubed. With the second derivative completed, we move on to what was asked, the third derivative. From the current result, differentiate it again. Place the constant out from the term. So the third derivative of y with respect to x is the constant 60 with the derivative of x cubed. We then differentiate. Y prime is then 60 times 3x squared with dx over dx, which is cancelled as 1. So finally, the third derivative of y with respect to x is 180 x squared.